The circuit that is shown here is called an instrumentation amplifier. And the instrumentation amplifier is basically a further development on the differential amplifier. And the idea is to make it such that the disadvantages of the differential amplifier goes away. So first, let's look at how the instrumentation amplifier works, and then we'll look at how the instrumentation amplifier takes care of some of the disadvantages of the differential amplifier. Okay, so if you look at this circuit, to the right of this line, this circuit is basically a differential amplifier, right? So if you know the voltages here, so if this is VA and if this voltage is VB, then we know the output. The output is simply going to be equal to R3 over R2 VA minus VB. But we need to calculate VB and VA. So let's take a look at how we do that. So let's take a look first at this circuit here. Now, what is the voltage at the non-inverting terminal of this op amp? So the voltage here is V1. So what will be the voltage here? It's going to be V1. And this point is connected through this wire to this point. So what's the voltage at this point? It's going to be again V1. Right? Similarly, what is the voltage here? It's V2. So the voltage at the inverting terminal here is V2, and therefore the voltage at this point is going to be V2 again. Now, if we have got that, what is the current going to be that flows through RG? It's very simply going to be V1 minus V2 over RG, right? Let's call it I. Let's just call it I. Now, where is this current going? So the current flows through RG, but can there be a current here on this path? What will be the current which is flowing in this particular branch? Now we see that whatever current is flowing here has to flow through the input of the op amp, and we know that no current flows through the input of the op amp, so this current is going to be 0. That's right. Very good. And so whatever current, so this current I is simply going to flow through R1 as well. And similarly, the current that flows through R1 is this R1 is also going to be I. Okay, if that is true, what's the voltage here going to be? It's going to be V1 plus this drop I times R1. So V1 plus I times R1. And what is this current going to be? This voltage going to be? It's going to be V2 minus I times R1. V2 minus I times R1. Now, of course, you can easily see that V2 minus IR1 is VB and V1 plus IR1 is VA. Right? So let me just clear a bit of space here and let's write the equation for V output now. So what is V output going to be? V output is going to be, we already said, R3 over R2 times VA minus VB. So R3 over R2, and then we write VA, which is V1 plus I R1 minus V2 plus I R1. And so we get that's equal to R3 times R2 V1 minus V2 plus R3 times R2 times 2 R1 times I. Now what is this I? So instead of this I, we can substitute the value from here, right? So what does it become? So what it becomes is V1 minus V2 over RG. Okay, so let me take this equation to another slide and we'll resolve it and see what the output of this circuit is going to be. So if we resolve this equation, what we get is we get V1 minus V2, and the gain becomes it becomes R3 over R2 1 plus 2 R1 over RG. Okay, so the gain of the instrumentation amplifier is given by this term here in the brackets here. Now imagine that we build this instrumentation amplifier in the manufacturing process, and what we do is we set R3, R2 so that they are exactly the values that we want, and we also set R1 so that it's exactly the value that we want. And the only resistance that we can change is RG. Now by changing RG, we can change this gain, right? We can change the gain of the instrumentation amplifier while not changing the differential properties of the instrumentation amplifier. That is, this V1 minus V2 term remains intact even as we change RG, because R1s, both the R1s are equal, both the R2s are equal, and both the R3s are equal because they are set in the in a factory setting in a manufacturing process. Also, look at the input impedance of this amplifier. What is the input impedance? As seen, because we are looking into the input terminal of an op-amp, the current that will go here is going to be 0. So the Rin is going to be infinite. Similarly, the Rin here is also going to be infinite. So the instrumentation amplifier kind of builds on the differential amplifier, and what it does is it does two things. One, it gives us an infinite input impedance at both the inputs, and secondly, what it does is it makes sure that we can change G by changing RG. That's only one resistor.